Ни для кого не секрет, что даже стопроцентное покрытие юнит-тестами не дает гарантии, что код рабочий. И не только потому, что проверки могут быть некорректными, но и потому, что, увы, протестированное по отдельности не всегда работает вместе. Подстраховать себя от этой подставы могут интеграционные тесты, но тогда все становится на порядок сложнее. Ведь теперь в тестах начинает выполняться куча всякого неподконтрольного. Например, магия спринга. Она может как помогать, так и мешать. Ведь в тестах зачастую требуется влиять на глубинное поведение фреймворка, чтобы заставить его возвращать то, что нужно тесту. О том, как правильно с этим жить, нам расскажет и покажет один из самых, пожалуй, харизматичных спикеров современности, полюбившийся нашей аудитории еще по выступлениям на JPoint. Опытный разработчик, консультант, Java-чемпион. Виктор Rentea. Please welcome. Hi, Victor.
Hello, hi.
How do you do?
Yeah, I'm looking forward to this. I've been preparing this all week, so let's see how this goes. Yes.
I'm glad. So please, can you tell me, how did the idea for the talk come to your mind?
Well, since I am teaching people, employees from many companies, I see them struggling with tests full of mocks. And I see them arguing, complaining that their tests are fragile, that they hate their tests because they break every time they refactor everything. So the habit of testing from too close by, with heavy mocking, leads to fragile tests. So the other idea out there is to write more longer scoped tests, more integration tests. But you will see that actually the name is not that correct. You'll see. So that's from a need of helping people to write tests that they can rely on, tests that really helps them and don't break when you refactor things along the way.
Okay, thanks a lot. So I'm striving as well to see and perceive all the information that you will provide us. So for the next 50 minutes, I leave you in a couple hands of Victor Rentea. Please welcome.
Thank you. So, integration testing with Spring. Let's have fun, shall we? Let me introduce myself. My name is Victor Rentea, Java champion, and I love simple design, refactoring, and unit testing. Actually, I have started a community in Romania, which is now more than 2,000 developers, focused on these topics: simple design, refactoring, and unit testing. If you want to join us, here is the link. I have a blog. I have a website on which you can find a blog, my best talks, and more goodies. And what I do for a living, I basically teach at various companies, and recently I've also started teaching open classes on Teachable. My comfort zone is, of course, the standard Java stack: Spring, Hibernate, functional programming, Java performance, and also topics that don't have anything to do in particular with Java, but that I'm really, really passionate about: design part of Spring Code and unit testing. And what we will see today comes exactly from one part of my unit testing training, really. Right. Here is my website again, and in case you want to find me, I am on Twitter, most responsive, but I'm also on other social media platforms. Right. So let's get started. If your tests talk to files, databases, queues, or web services, and those tests are typically referred to as integration tests. If your tests talk to these, and imagine one of those tests fails. Is it a bug? Well, it might be because the database is down or the web service doesn't respond as it should. So the first thing you think is, oh, probably not. I hope not, right? This is human psychology. If something cannot be your fault, then certainly that's the case, right? And you get this wishful thinking. And after several months, after you get to the team and they say, they tell you that, our tests fail occasionally. It's normal for them to fail. I will call this that they've developed a failed test tolerance. They get to live and they get to believe this is true. This is okay. This is not okay, because among those 10 failed tests that they have every week, there are 2 or 3 bugs. So this tolerance against failing tests is no good for your project. Now, this classically is referred to being the integration tests, which depend on other systems, right? In those integration tests, however, if something goes wrong, may not be your fault. It may be just due to some external systems. In contrast, a unit test classically is believed to be to always indicate a bug in your code. Right, now, integration testing typically are deep, to go to many layer, whereas the unit test classic is thought of as being just a fine-grained, typically with heavy mocking around, testing a little method or part of a class. Now, integration tests are slow because they get to start containers, they get to talk to network, they are slow. Whereas the unit test, it's typically very fast. In my production systems, I have close to 100 tests per second running on my local. And the integration tests are also fragile, and that's what annoys me most, because a test that you cannot trust to be failed for a good reason, it's what we call them Flaky tests, tests that go, either they fail, either they pass, you don't really know what they really want to say. In contrast, unit tests, so basically, I'm not very happy with the naming that we are using. Integration tests don't mean, technically speaking, I mean, people, when they say unit testing, they always think of testing a method or maybe several methods in a class surrounded by mocks from everywhere. This is not the definition of unit test by Kent Beck, the inventor of unit test. Let's drop this naming convention for a second and let's just talk about Flaky and honest test. Now, a Flaky test is a test that depends on another system, on something that is out of your control, whereas the honest test will always point to a bug. Now, there can be some honest tests which are particularly slow, those that start a database in their memory. Now, this is still an honest test because since your database is private to your test, is in your Java process memory, you can't really be influenced by anyone else. So it's still an honest test, but it's slow. And that's actually exactly the purpose of this discussion today, that I will show you how we can bring more and more stuff from the Flaky area into the honest area, and then to trust them. And then you know what you can do. You can have this. You can use this separation in order to aim for zero, to build a zero tolerance for failed tests. I do not want the teams to comply with a failure in a test. On the contrary, when the test goes red, I want this to start in your. I want this to turn on. When the test on Jenkins fails, this should turn on. Right? And I actually saw this on one of my clients in Belgium. They had this connected to a laptop connected to Jenkins. And if the Jenkins was turned red, then this turned on. And everyone was just focused on fixing those tests as soon as possible, right? I want this to happen. I want zero tolerance for tests. Now, what we'll do today, we will start with testing a search for a product in which there will be a name and a supplier. That's what we will discuss. We will use 4 kinds of databases. First of all, when you will test such a functionality, you could go to your database that you use also when you deploy your application, right? But that's not very fun because there might be data in there. That server might be turned off or whatever, or the schema might not be up to date. The second database, we won't actually go there, really. The first that we will use an in-memory database, H2, and then an H2 standalone in the same machine, but next on a separate project. And then the fourth one, a database in a Docker. We will try to get to all of them. That being said, let's jump to code. Right, this is the search that I will be testing. It's selects from product. I'm using Hibernate, and where 1 equals 1, I will refer to this to be the one equal 1 kind of query, of search query. This is a dynamic query because to this string you get to add different criteria based on the different filters, different constraints that the user gave in the search form. So you get to concatenate GPQL like this. Right. And then the parameter put here, you also define in your map. There are other ways of implementing a dynamic search. One of them is criteria API. Another better one is criteria API plus meta model. Then there is query DSL, and the most geek of all is the specification from Spring. If you didn't know of all these, Google them. They are quite good. But however, despite all these, I still use this in my production systems because this everyone understands. Right. So this is the function that we will test, and this is a test. I have to start off. Well, I have 2 tests written already. Each of them, they will insert a product, and then using some criteria that is not filled with any kind of criteria, they will basically issue a search with no criteria. And what I will expect to see in the first case is that I will get back that product that I've inserted. This can only happen like that if the database was empty, right? Now, let's try first to run this test to see what happens. Right now, I've just put Spring Boot test on it, and this started behaving like a Spring Bean in the sense that you can inject things in this test. Right. Now, the first thing the test will try to do when it will start Spring up, it will try to connect to a database. But the database, the production database is not accessible. You can imagine, the production database is not accessible. Let's imagine, it's not there. I don't want to connect to that database because they might have stale old data. But however, this is the exception that you get, that you cannot connect to that database. Like, of course, you just can't. Imagine it's down. So what do? Well, I will like to connect to an in-memory database. Let's try that. Active profiles, and I will say dbmem. This dbmem part point basically tells Spring to load this file, application-dbmem, and override all the properties that are defined in it, reassign these properties to these values, like this and this. Right. So now I'm going to a database in memory, the H2 database. Let's see what happens now. So I have a private database over here, started in the memory of my test. Well, the first test goes green, but the second one goes red. Woohoo! Let's investigate. I will run just this. Let's see what happens. I will run the test that failed to debug it, because it's the same if you look at it. Let's see. And this is you debugging something that went wrong on Jenkins. And this one, this time, goes green. What the heck? It was just red, but now it's green. This is the definition of a Flaky test. You can't really trust them, honestly. So basically, you get to ask yourself, why does this happen? Why is it so? It's the same kind of criteria. I'm inserting the same kind of test. I'm inserting the product, and I'm searching for that product. Now, if you write them both, they will fail. But you see, the failure message is not very helpful. Let me show you. The second one will fail telling you that expected 1 but was 2. If you ever see this in a production system, I trust you will not be very happy, especially in a large, complicated code base. You would like to see more than that. And just for a second, let me drop the assert equals that we've used. And let's switch to another another assertion framework, which is called assert4j. Right? And from these assertions, let me show you the actual. I can't see the actual type yet, but it's assertions from, it's here, assertions. It's from the assert4j library. And this is very handful because when it fails, it will look at how I wrote the test, right? I gave the list to the framework. And the framework, if the size of the list is not equal to 1, it will print a toString of that list, showing me that I have 2 products. Which product? Product A and product B. There you go. So it somehow, the second test, the BIS test, sees the data that was inserted by the first test. And I can't believe that. I mean, I can't believe my eyes. Is it so? To see this clearly, let me switch to a separate database server. This time, I will not start an in-memory server, but instead, I will connect to an existing one running on port 9092. And the database that I will connect to is right here. It started, and it is just waiting for me to run my test. I will switch to a different. Why do I do that? Because I want to inspect the content of the table product. I want to see clearly that there are 2 rows inserted in that table. This is because really this first. I should run this test. This happens because basically what's really going on. This test influences the second test by the data left in the database. Let's see this. In the product, after all these tests will run, let's see if what am I left with. Let me have the test running first. Oh, there we go. There are 2 products left in the database after the tests finish. Right? That's because my tests actually flushed the data to the database, inserted stuff. Yeah, one idea would be to have them delete their own data, like repo.delete all. Right, and you can delete them after each. But then if you do that, really, if your your search query doesn't really return the proper results, if you look in the database to try to run the query manually, you will find nothing. That's why we typically delete the data before we even start. But if you do this before every test, why not using the before each for that? And putting this in the before each, just to make sure that every time we start a test, I will start by deleting everything in there. That's quite interesting, and that's actually one of the only ways you can, one of the most efficient ways you can do it for a NoSQL database. Or if you were talking to a Cassandra or to a Mongo, that could be a very good idea to delete, maybe manually, the things that you don't want. There are other ways, however. One idea. There you go. Now they both pass when they are run together, which is good. If I look in the product table, I will see only the last test ran, which would allow me to debug if the query didn't return me the results I expected. Good. Now, just for a moment, let's imagine that I would like to test also another functionality. Let me point you to the proper one. Yes. I want to test the search by supplier. That's what I want to test. Let's try that. So, by supplier. If I do this, I will have to have a supplier for this product. Let me try to do this. New supplier. Right. Like this. And then this supplier is bound to the product. And then this supplier, let me make the variable from this. Variable supplier. And this supplier will have an ID. Supplier get ID. And this ID is what I need to put in my criteria. Criteria dot supplier ID equals this. Now, if I search by that supplier which is bound to the product, I expect to see it. But if I search by something which is not bound to, which is not the right thing, like -1, I would expect to see it is empty, right? Is empty. It's a quite interesting way of testing it. Good. Now, what will this do really? I would like to have my product inserted, but also, if you look careful, then you see that product has a supplier. Basically, the supplier is a foreign key, is another entity of my product. Let me just show you that. My product has a supplier like this. So I would like this to be also inserted in my test. However, let's see, will it work? Will it work? Let's see. Let's see. Oh, no, because it says transient property value exception object references an unsafe transient instance. Save the transient instance. It tells you that actually you are trying to persist product, but the supplier reference here is not yet known to Hibernate. What I can do instead is to go here and say here Cascade equals persist, which is something very useful in your test. Excuse me 1 second. So basically, this is very, very useful in test because it allows to cascade the persistence to the things that you want to insert along the way with you together. So this is very, very helpful in writing simple tests. So there we go. Insert the supplier, cascade the persistence to that, and now it runs. But you can imagine that this leaves stuff in the database. Let's check that. In my database, in the supplier table, there is the supplier left. Afterwards, right? But what if I want to clean this state? What if I want to clean that here? Let's try to clean the supplier. I have a supplier repo. Let me inject one. Auto-wired, private, supplier repo, and the supplier repo delete all. Right? Like this. And now let me do one trick. It won't be obvious why I do it, but I will put an A in here. This A. Mysterious. What's that A for? This test ran the last one. I've put this A over here to tell you that the order of the test is not the order that I'm writing them in my class, but is decided by the name that they have. This A there caused my test, although it is the last one in my class, to run the second one. So what, you will ask? Let's see what happens. Again, this test leaves behind both a product and a supplier. And then when the third test tries to delete that, you get something very strange. Foreign key violation. You cannot delete from suppliers because there are products referencing that supplier. Oh my God. So the order matters. You should delete them in another order. Ouch. Very painful. Foreign keys, you see, if you delete this way, it will work. But this is so weird, right? I mean, whoa, what's that? Really? That evil? Let's see. Basically, what I showed you now, manual cleanup and test. Yes. So the order tries to matter, and if you imagine a large schema with hundreds of tables, this quite becomes a piece of mastery how to delete all the tables, in what order you should delete all the tables. So to help us with that, let's clear data SQL. Let's create an SQL for that, in which we will delete from Supplier, first we need to delete from product, right? And then delete from Supplier. Right, in the proper order, first the product, then the supplier. And then let's try to reference that in our test. So instead of deleting them with Hibernate, I could do the following. I could reference that SQL that I just wrote with SQL, pointing it to scripts equal class path, and then saying clear data SQL, control space worked, and then phase, something with phase, execution phase equals when do I want to run it before each test method. Perfect. And this effectively does exactly the same thing. Deleting the tables in the proper order. You get the point, right? Everywhere where I need to wipe out the data from my database, I will use the same script. Right. Very, very, very useful in applications with many tables. Right, so before every test, these will get deleted. Right. What do I need to show you? Let me inspect a bit. So I've showed you how to initially, I want to show you that. Manual cleanup we did. We did SQL. And now, there is another way to delete everything from your database, which is to basically destroy all Spring. It's called dirty context. And you say class mode equals before each test method. Now, what's the difference really? Let's look at what the current output was when I cleared the data. First of all, we see Spring started here, and then we could see, I didn't see it yet, but we could have seen the deletes happening. Fortunately, unfortunately, I'm not intercepting those SQLs. Let me do that. I reverted back to my SQL script, and now let me hack a bit the connection to my H2. So my H2 is a standalone server running next to me, and I will go now to this connection and say the following. So folks, pay attention. This might be the best thing you see in this presentation, right? After GDBC and before the remaining of your GDBC URL, type p6spy. P6 spy. Change the driver to P6 spy. It's a jar you need to have in your class path. It's a dependency you need to have. And just do these two changes and run again to see what happens. The same password, the same username, but I'm switching the driver to P6 spy and I'm adding it over here. What will that do? That's a GDBC driver proxy, which will effectively look for the proper driver to which to delegate all your calls to, but it will also log everything in your console here. Intercept every GDBC on the wire level. There you are. This is P6spy intercepting your calls. And you can now see for each test that the delete from product, delete from supplier happened here. Interesting. So those deletes that from the file are happening, as you can see. Right. Now, I wanted to tell you about this one. Let's see what this does. Dirty context class mode equals. Now, let's imagine a bit. Basically, you have a Spring. If you look right now in the output here, you saw a single banner. There was a single Spring started. When I put this in place, my Spring context will will be destroyed before each test method. That's why you now see multiple banners in your output. Let me just check. Let me show you. This is one banner. This is another banner. And this is actually three banners, even worse, not only three, yes, 1, 2, 3. So there are multiple Spring contexts starting in your application, and this in a real application is a terrible penalty, because every time Spring starts, needs to do a lot of stuff, like hibernate, inspect the entities, generate the meta model, persist, drop, create if you are recreating your schema every time, like I do right here. If you are recreating the schema every time, then it will recreate the entire database schema for every test. So this is a very dramatic performance impact in your test. And I would not recommend using this on a regular basis. But still, this context is a way that you can check that nothing in Spring can cause interdependencies between your tests. Right? We saw three things: manual deletion, we saw clear data SQL, we saw this destroying entirely Spring. Unfortunately, none of these three is the best way to do what I'm trying to do, to make isolated tests talk to my database. The best way, the best way, is to mark my test as transactional, my test class. Now, this is the same implementation you know from Spring. This is the same implementation you use in your production code. But when you put it on a test, it gets different semantics. Spring interprets it differently. It says, wow, you want to do a transaction for each test, don't you? Now, okay, I will make your transaction. Okay, go, fair enough. But you know what? After your tests, does it make any sense to commit that transaction? Well, no, it doesn't. Basically, all your transactions that are began here are rolled back at the end, as you can see, automatically. So each test is run separately in its own transaction, which is rolled back at the end. You can insert your supplier, your product, whatever you want. You insert everything, and then you run your select to check the things that you want to check. And after your assertions, after you've really checked what you wanted to do, then at the end of the test, the transaction is automatically rolled back by Spring. This is the way of testing with a relational database, right? Using isolation, you isolate your stuff from any other test. You can actually get to run tests in parallel if you insist a bit on the same real database if you want, with the condition that no tests leave anything in the database after it runs. So transactional tests is clearly the best way to go. And P6Py also came very helpful to show me clearly, black and white, that I am doing a rollback. But am I safe if can anything wrong happen if I do this? I mean, yeah, this transaction started here, will propagate in my production code. Okay. So in my search, really deep in my this search method will run in the same transaction which is started from the test. But let's imagine a horrible scenario. Let's just imagine that just before returning, this method calls another class with a method in that class. This other. Good. This is a service, and this is require ask constructor as you should all do. And then this other should also be injected there. So I need private final other, and because I'm generating the constructor with Lombok, it gets automatically added to my constructor other.method, and this method tries to do something with private final entity manager em, and then on this entity manager I will persist a new product, which is by mistake, or not necessarily by mistake, but it's something that you did not expect to happen there. And here comes the bad news. Transactional. This method thinks it must run in propagation equals in a different transaction. Propagation requires new tells Spring to open a new transaction just for the sake of this little method. What this will cause is that a second transaction, different than the one started from your tests, but a second transaction will be started for the purpose of this little method. Inside that little transaction, persist will run, and that second transaction will get to commit to my database, leaving garbage behind. And because now the tests leave products after they run, you will see that they. Let me just check it out. Yes. The first run successfully, the second one, but the third one, kaboom. The third one, it says, I expected to see just a single product, but you got me 4. Okay? Why? Because by mistake. It's those things that you've left in the database from your method. So even if you use transactional tests, you can still run into trouble if your code opens new transactions. This is not very common for handling HTTP requests, but quite common for doing long-running processes like batches or imports or stuff like that. Whenever you use requires new, you sacrifice the ability to unroll, to roll back a test transaction that covers that piece of code. But then what do you do? Because in a real application, in a big one, this will happen. And it happened to us. And we ended up doing the following. You may laugh if you want. I don't care. This is what we do. We did find all, and we asserted that this is empty. Where? In the before. I wrote an assertion in the before. Why is that? Because when my test fails, telling me that I did a mistake in my test, the first feeling is that you broke production. Well, in fact, what happens is that the tests are influencing each other. So what I've just built here, this assertion, ensures me, checks, even before I even start doing anything from my test, ensures that there is nothing left in the database by previous tests, that my database is empty. Right? I could have deleted them, but honestly, they should not leave anything behind, to be honest. So that's why now the test will fail telling you that it crashed from the before. It didn't even start writing the test. Right? I was expected to have empty in the database, but it wasn't empty. So this is useful, useful for real world large projects. When you don't know, when you don't really trust, it's prudent. It's prudent to do that. Okay. That being said, I will drop this from here. Actually, I will drop the code, to be honest. I'll show you the point of nested transactions. Oh, but let me also show you what really happens. With P6Pi, it becomes a piece of cake to see that there are two transactions over here. Connection 1, it's the second transaction in which you do an insert and a commit. And the blue transaction, it's the first one, which did a insert and then a rollback. You see, the blue one was rollback, where the red one was committed. And that's the problem. Very easy to do. So if there's something to take out of this presentation, please take the P6Pi stuff. This is incredibly useful for every application. Incredibly useful. This technique can save hours of debugging and breaking your head. Right. Good. So we've seen transactional tests, we've seen P6Pi, we've seen nested transactions. Good. Let me put some slides first. We saw how active profile can tell Spring to load a different set of properties and to override some of the properties that came from production. Override some properties from production with a special file. Then we cleaned up after test. Actually, we cleaned up before test because we said we don't want to clean afterwards because we want to leave the data in the database for debugging purposes. So we clean it before the test. That's what the manual cleanup. Then we also tried dirty context, in which case Spring dies if you do that. And if you do that in a real production system, you will waste up to 1 minute. It might take up to 1 minute for your Spring context to boot up. If you have a lot of tables, a lot of endpoints, it will take a lot of time to start Spring. So this is only useful to debug your test dependencies. Do not push it to Jenkins. It will slow your pipeline quite a lot. Then we saw this dirty context. I told you it's safest, but wastes time. We saw manual deletion, right? And it's actually best for non-transacted resources like cleaning files or NoSQL. We saw transaction, which is the best way of testing with a relational database, right? And also the trick to check that what you have at the beginning of the test in the before is what you expect. In a large application can save you a lot of trouble. And again, we also saw that even if you put transaction on the test class here, you can still run into troubles. If someone down the line opens a new transaction which requires new. And now we'll come to another issue. How do we insert test data? That might be a silly problem at first. You might say, that's a big deal. But some data you might want to cascade persist right when you start your test. But other things you might want, for example, imagine this product. I want to set it let me just commit this first. Say stage 1. I don't know. It doesn't have a lot, but commit. Yeah, also this one. And commit. Come on. Pushing. Now, I want to set on this product. I want to set the user who created that product. Let's imagine this scenario. So set created by. Now, the user that created that product, I could insert it here, but it feels awkward to insert a user in a test, especially if it's too much. Many people won't find it okay to cascade the persistence from a product to a user. To put Cascade here might feel awkward. So let me show you some ideas you could try. Let's imagine that you want a user here, but you want to persist it separately. One idea would be to put it in the before. Let's do that first. I will first auto-wire private user repository, and in that user repository, I can do persist or save the new user, which I could then maybe put in a field. Let's try this in a field called user. Does it work? Yes, user equal. Good, but many tests might want that. Right? User can be then used here. And by the way, the before runs in the same transaction as usual. Many tests might want that. So to make that happen, you can take all of that from here already and put it in a superclass. And I didn't saw any real production system that doesn't do that really. Repo test base. Let's name it like that. In this repo test base, first of all, it needs to be in the test folder, not in the main. And this one is make it abstract. Good, and paste it here. Good. Now, the user that I'm creating here should be accessible to all the subclasses. One other weird thing that will happen, let me try to extend. Yeah, I extended. Something strange will happen. Before has the same name as the one inherited. So let's change the name, insert user. Right. So basically, every time you insert from this class, you get the user automatically inserted in the database, which is quite convenient. But you can do more than that. You can take these annotations from here, all of them, and put them on the base class to make your test cleaner and simpler, basically. Good. Let's test this one. Let's see if it works. So basically, I don't need this here, don't I? I can read this, right? So I'm inheriting the user from the superclass, which is quite useful in practice. There are the metadata, the current user that you want to have in the database, in order to be able to set the created by to that user, for example. Right. Let's see. By the way, in the meantime, please put these in your tests. It will help you a lot. I gained 3 seconds, 2 seconds, just with this. From 5 seconds, you dropped to 3 seconds using this. So try this for your own case to see what happens. If you can gain some time running those tests locally, it speeds up the boot time of Spring Boot. So now I want to see the user inserted. Didn't put it a name, but I still want to see an insert into user. There you go. Insert into user, and I can see it happens in the same transaction, which is then rollback at the end. So the before that I inherit from above, it runs in the same transaction as each individual test. Right. This is the only way to actually do that in GUnit 4. But since GUnit 5, we have another option. And I want to show you that. Because it becomes awkward, because in this superclass, there will be a whole bunch of stuff piling up. I don't like that. It's too dirty in a sense. That's why GUnit 5 brought us what we call extensions. These extensions, right? You can do stuff. For example, you can get the Spring context, and from your Spring context, you can get the bean, which is the user repository class. Come on, woohoo! Class. There you go, and you get this user repo. Bean, really? Bean? User repo, and then in user repo, you can save the user that you then expose. So folks, this is just a Pojo, right? Nothing fancy, implementing something from Jupyter, from Unit 5. And you just can call this to the party with the following technique. Public, common data extension, data equals new. You just do that, and you put here register extension. And instead of inheriting from a class, you can put maybe even more than this, right? To make all of that work for you and do their stuff in the database. And then that data has a user inside that you can access. So you see what happens? This thing is like sort of it's like an aspect, really. It can run before or after your tests to do stuff, such as persisting. But it's very interesting. You use these by referencing them, by composing them, not by inheriting from them. So it's very powerful, very flexible. You can have many things happening around here. Let's Let's see if it works. Alt 4. Answer data unit 5. Okay. You can also use SQL for this purpose, by the way. As we've discussed, it can run your SQL it will run them in the same transaction as your test transaction, inserting common reference data such as countries, labels, and stuff like that. Right. One more thing I want to show you. Once you've created this search, these tests, you would love to have confirmation that you've understood correctly the requirements. That's precisely the purpose of writing a feature. Folks, this is Cucumber. Actually, this is the Gherkin file, and the library that I'm using to run this as a test is called Cucumber. Let me show you the test that will run on Jenkins, and if you run this on Jenkins, this really works. This runs with Cucumber, loads error passing feature file. Actually, it doesn't work because I have some comment, I think. Let me see if these are the case. In this up for a second. Run again. If you run this on Jenkins, it will load this feature file that you see. It will enable Spring integration, and it will link basically. What's this? This is a text file, right? And since I'm claiming that this runs on Jenkins, how the heck can this run on Jenkins? Every line from here corresponds to a Java method. There is an IntelliJ plugin who knows to get me there. But there you go. Let me put the feature file in the left-hand side so you can see it for yourself. That product has name. That product has name. This weird stuff here, don't need to read it to write. It will be generated. If this weren't here, this step will turn yellow. You can alt-enter it, create step definition. You don't really need to write it yourself. It is automatically generated by the plugin. So what I mean here, really, you get to a human readable specification. Let's try to read it. Given there are two suppliers in the database, and by the way, these insert suppliers. Then let's try this one. If there is one product in my database and that product has name, if I search for name X, then I don't get anything back. Every such line corresponds to something implemented in Java, as you can see. What it means, no products are returned. I'm searching and I don't get nothing back. Cool. That's nothing, folks, compared to what comes below here. Just watch it. That product has name, product name, and these are variables. Yeehaw! Variables that you can use, and basically every such line from this table becomes a test that gets to be run. Let me show you. Look, these two lines, they were both ran as. So basically, for each one line, Cucumber takes these and runs them once. Next line again, and so on. Let's add one more criteria. One more search combination to get the point. So if the product category is X, because I know X was inserted in the database, and I'm searching by supplier X, and I'm searching by Y, I don't expect to find it. But if I'm searching by the same, then I would expect it is found. But this, every line translates these sequence of steps being run one after the other. And you know what's the best part? They all run in their own transaction. Yeehaw! So they all run in their own transaction. Yeah, isolated from each other. That's the integration with Spring. That's super cool to use. And this you can put on in front of your analyst and have them ask them, wait, I did a mistake, right? Yes. It shouldn't be true. It should be false. And it fails. Look, this one with true. It should not be true. It got 0 from the database. It should be false. You get the point. So Cucumber, you can run all of that what I've showed you, exposing the tests as Cucumber steps, as you can see here. Right. Good. Now, what's more to show you? I wanted to show you one more thing. I'm not sure about the time, but let's try to cover that too. I may be running out of time at the end, but I will wait you in the question room for more discussions if you want afterwards. But I really want to show you one more trick here. Now, I think it's improperly to do that first. So, how can you insert test data? You can insert it in the test itself, in the before each, in a superclass that does before each, or in a register extension with unit 5. And remember, Cascade Persist helps you a lot to save the things, to cascade the persistence on the child, on the children of your entity. That I didn't show you, but that I didn't show you either. But SQL, it's quite natural. You can understand it. Runs those scripts on you, right? SQL. Read this in case you are using a lot of PLSQL, a lot of complicated queries, or my bodies perhaps. This helps a lot. Now, next one. I want to test one more thing with you. That thing is called product facade. Let's just read it once and let's see how it goes. It's a create product. Let me generate a test for it. Don't I have a test already? Yeah, I have a test. Let me put the test in one side, and this is the production code. This is the test. Let me see the production code. So I have create product. When I get inside the product DTO, then this create product, first thing that it does, it calls safety client to check that the product is safe. Now, is safe turns into a REST call over network. And that's tricky, because if you are trying to do a network call from your tests, from Jenkins, it might fail because that system is down. So I want somehow to take this out of here. I want somehow this safety client to, I don't want to really call that network. If I run my tests now in my DBMem, and one more thing I want to put here, though, it's called transactional. Just realized I forgot to show you one thing. In the previous example. I forgot to show you one thing. It can happen then that you want to run your queries on, where are you here? It may happen that you want to use some database specific features that don't allow you to run on H2. You may want to use some max over partitions, some things which are specific to some database systems. So then what do? You would like to run, for example, on the very MySQL itself. But where do you get the MySQL? We could connect to a shared one, but you get to the same problems. These are not reliable anymore. That's why you can do the following. You can tag these to be integration tests. You can, and then based on these you will run these integration tests connected to a MySQL deployed in a Docker. If you deploy in a Docker, you have to wait for the database to become available. Context configuration, initializers equals to wait for database. You can inspect the code afterward. This trick delays my tests until the MySQL came up and is ready to be used. And then if you do Maven verify, which will take you to the failsafe plugin, the failsafe plugin is configured here. You can inspect this afterwards, but the main pieces are the following. The failsafe plugin will run only those tests which are tagged as integration. And another plugin that I have in here will start Docker before my integration tests, pointing to Docker Compose YAML. This Docker Compose YAML is a file which starts a MySQL. And that's it. Basically, this will run on Jenkins with the condition that you have Docker installed on your Jenkins server. There you go. It just created the Docker instance, the MySQL Docker instance. Now, I am waiting for my database to come up. This little utility I wrote myself to postpone the start of the tests. It's very easy with a utility. I will share the Git with you. And at some point, the database image comes up and is available, and the test will start running, hopefully. Let's see. And to connect, and there you go. From now, at this moment, a connection established with MySQL database, and the test starts running on the real MySQL database. So you can actually Dockerize your dependency. Those exceptions don't matter really because we're from the DDL from Hibernate. But look, Test 3 run, 0 failures. So this test that we worked together now runs on a real MySQL database deployed in a Docker. Right? Dockerized dependencies, which is very, very, very powerful. Now, it will take me, I think, 5 more minutes to show you the second example. Should I do that? I'm wondering. I do that. Let's try. Here. Let's do this. So we have create product. There. This is the product Facade. This is the test. I'm running in memory. I have a transactional test. And what happens? I am calling this function. As I explained, this will get you to safety client is safe, which will call REST outside. If you are trying to run this test locally, it will fail because there is no such localhost 18890 opened that will answer to this request. So this will fail in your case locally. Let's see, because you are connecting to a network system. I want to do one thing, however. I want just for fun to see what happens if I am starting a system. Where are the integration test safety app? Yes, command. And MVN, how is it? MVN Spring Boot run? I think Spring Boot run. Did I get it right? Let's call it that way. See if I boot run. Yeah, I'm lucky. Good. So I'm now starting the real service that I'm trying to access. I just started it up. Let's see if it runs. Yeah, kind of runs. And let's see if it starts on 1890. Start the safety app on 1890. Good. Now, this service now just became available again. It is available. If I run my tests now, it might pass because the service is there. But how can I guarantee that that service keeps returning me the same values? And how can I run these on Jenkins and still trust them? There are 2 ways you can do this. This is green. One way is to not call it at all. What do you mean by that? I mean that instead of in my Facade, in the test that I want to here, whenever I'm about to call this, I don't want to really call it, but I want to have a mock to replace this safety client. How do I do that? Well, not auto-wired. You all know about bean, probably. It's from defining manually bean, and you all know about Mockito. And there is MockBean, who is basically the combination of Mockito and Spring, which basically define private safety client. You basically define a Mockito bean and put it in the Spring context to override the safety client. And you can then program that whenever safety client is called, when from Mockito, safety client is called with the method is safe from any string, I don't care right now, or I can actually point it out to UPC. This is UPC. If I call it with UPC, then return true. Why true? Because I do not want to get an exception later on. This is a Mockito bean which overrides a definition of a Spring bean from your context. This is the simplest way to cut out that dependency, but it's not the most robust because there is code which is not tested at this point. You didn't ever tested this one. You didn't ever tested that this thing is right. There's still a missing piece in here. You are cutting out a part, but the test is green. Although I have stopped the application, as you can see. So my test continues to run even if the external system is down. But can I do it better than that? Let's see. This is, I will commit this. I will call it MockBean tests. And then let's see the next one. I want now that the next challenge, the last challenge is, can I somehow get this also under tests? Well, the only way you can do that is to let the call happen to some HTTP endpoint. But what HTTP endpoint? Look what I will do. I will override the property which keeps the address of the safety service that I'm about to call. And I will tell my production code that I don't want it to go to the standard one, but I want to go to 80, let's see, 80, not 80, 90, 8099, for example. On 8099, I will start register extension, and I will say public wire mock extension. This is extremely used by my clients. I see it used a lot, quite very much. And you mentioned basically the port. What will this do? It will start up a HTTP server which listens to this port and responds with stuff. With what stuff? But wait a second, I'm cheating. I should have cut out the MockBean. I'm not faking any bean anymore. I leave the whole stuff to run, but I am exposing an endpoint. I'm basically pointing my safety client to this wiremock service, to my wiremock extension that listens to port 8099. Let's see what happens. In the meantime, in resources, in mappings, there is somewhere around this file which says that if you go to product UPS safety, then this product is safe. And my test passes. Whoa! My test passes because it called an HTTP endpoint. It called wiremock. There you go. Wiremock. Go to answer from remote API. Product UPS is safe. This is the code for my safety client. So my safety client called wiremock, and wiremock responded based on these files kept in mappings. Right. And now for the last challenge. Let's see if I can make it in 3 minutes. Let's see. Here, I want the terminal. I will do Java minus bar. In the meantime, I will leave you looking at this. How do you run it? Just Java jar, wiremock, recording, standalone jar. Now, what happens? I will just start, and this is wiremock. This is a server running on 8080. I can access this server here. I'm getting out of time already. I will just show you the point and let you explore it. Can you imagine what this will do? Wire mock recorder. You get it to target URL. I will put it the 8090, the real port here, and I will point my application to it. I will point my application to the wiremock recorder, and then my wiremock recorder will forward the call to the real service, and then the response back to my application, while also recording the JSON which went through it. Just read about this. I don't have time to show it, but read about this. This is the link that you should see and you should check. Now, to wrap up the stuff, let me just put some more conclusions on the table. What database to use in your test? You can use an in-memory H2, like I did, in case you are only using GPA and standard SQL and nothing fancy. If you want to do some native features of your database, then you can start it in your Docker. But you can also have a real physical database that you can run your tests on. And for some legacy systems, that's the only possible way, actually, it's the only solution. But for most new applications, or let's say decent application, you could try one of these two. Now, it might take you a while to put Docker on your Jenkins pipeline, but it's so good. So try it. We saw assertions. We saw, actually, you know what? I will skip that slide and I will get you to one more thing. Gherkin language, we saw this. Given, when, then. Right. And these translate to Java code. These translate to Java code. We also saw MockBean, yes, of course. Mock and bean, and together MockBean, right? Which will replace your Mockito mock. We'll replace that Spring Bean with a Mockito mock, and it will reset it after each test. Right.
Thank you very much, Victor. Thanks a lot for speech.
Yes,
Can we
basically
go on in discussions on?
Yeah, we could continue the discussion. Basically, this is all that we've seen. If you want to ask me more questions, there are some things I didn't get to show you really, but if you want to ask me more things, let's go to the Q&A room and discuss more there.
Thanks a lot. Let's continue there. Thank you very much.
Thank you.
Happy to see you.